Yes, even fun.
So welcome back to the Making Data Simple series, and welcome to 2018. I'm not sure about you, but years go by like minutes, it seems like, particularly the older you get. I don't feel like I'm that old. But we're excited about 2018. I desperately want to thank all the listeners out there because we have been growing exponentially beyond my expectations. So thank you very much. We'll continue to find interesting topics and folks to bring in that talk both technology as well as leadership and everything else under the sun. I also want to thank the producers that work tirelessly on this, as Kate Nichols and Fatima Sarindi. They find the great guests, IBMers or external to IBM industry experts. And I know that they have a few surprises for 2018. So stick around, please give us feedback. And if you're on iTunes or elsewhere, please rate us. We like to hear how we're doing. So thank you, and here's to the new year. Welcome to Making Data Simple. This is Al Martin. I have with me today Judith Hurwitz and Dan Kirsch. So welcome, guys.
Thank you.
Judith Hurwitz is the president and CEO of Hurwitz & Associates, a strategy consulting and research firm, and they're focused on distributed computing technologies. Dan Kirsch is also at Hurwitz & Associates. He is a research analyst focused on security, governance, and privacy. So we got some big hitters today. The topic that we're going to delve into is machine learning for dummies. And before we jump in there, I see that both of you have very accomplished careers, and I would be remiss if we didn't have a formal introduction. And we'll start with you, Judith. I am not the sharpest tool in the shed, but I do notice that Hurwitz & Associates also matches your last name. If you could start there, please.
Certainly. So, as you said, I'm Judith Hurwitz. I've been in the industry for more than 30 years. Also am the author of 8 books. In fact, one of our most recent book is called Cognitive Computing and Big Data Analytics. So that came out around 2015, and we continue to do a lot of research, thought leadership content. Dan and I are both spending a lot of time right now on machine learning, AI, and looking at that also in the context of the hybrid cloud and the requirements for security. So it's sort of ironic that the 3 topics that we spend most of our time talking to customers, researching, analyzing are all coming together. If you look at cloud, if you look at machine learning and AI and cognitive computing, as well as security, they're all intertwined right now.
Fantastic. Thank you so much. Dan.
I'm Dan Kirsch, Principal Analyst and Vice President at Hurwitz. Been with the group for a number of years, but been in the industry for fewer years than Judith. So what I've been focused on, along with Judith, is machine learning. And as Judith mentioned, we're really seeing machine learning throughout technology. So we're seeing people applying machine learning to security, to hybrid cloud management. And it's exciting just because these are the areas we focus on, and we're seeing it all intermix.
Fantastic. Thank you both for being here. I greatly appreciate it. So with this podcast, I like to provide a ton of differing point of views. I give mine from time to time. In fact, I just did a keynote that I put into a podcast that talks to, my point of view and the overall Making Data Simple strategy, if you will. Today, you guys are kind of on the hot seat in that I want to start with the book, Machine Learning for Dummies. I want to dive in further, machine learning specifically, and then come back to the book. So hopefully that's okay with you guys. Sound good?
Sounds good.
All right. So first of all, let me say that I thought you did a nice job with the book because I often take notes around machine learning, and I noticed almost every topic was essentially outlined in the book. So it was very comprehensive. So kudos on there. I want to start by, as you already mentioned, Judith, you have several books for dummies, and you got a perfect audience in me right there. But why machine learning now? And I'll kind of preface that saying, but one of the things you talked about is what is old is new again. And I agree with you because despite the hype, machine learning is really not new, nor are neural nets. In 1959, and if I could give a shameless plug to IBM, Arthur Samuel created the program to play checkers. You even have this in your book. In 1996, Deep Blue beat the world champion in chess. And in 2011, we took on Jeopardy. But when you wrote Machine Learning for Dummies, is it because it's just a relevant topic in the industry right now? Or do you feel like we're on some kind of threshold?
As you were saying, machine learning has been around for a long time. I think why now? Because I get a lot of those questions from people. Why now are we talking about machine learning and AI, neural networks, when they've all been around for a while? Why now? And I think the reason is because, again, reaching into some of the things happening with cloud. With cloud, we've gotten to an era where storage and compute are much cheaper than they were in, let's say, 1959, where you could not afford to store as much data as you need for machine learning. You could also not do the level of compute and sophistication, performance of compute that you need. So setting that aside, that now we have the ability. We're sort of in an era where we've reached as far as we can go with traditional programming, which is why you see the advent of microservices and containerization, and you're now seeing that applied to data. We typically wrote code based on our prejudices and our assumptions about our businesses. What machine learning begins to give us is the ability to use a variety of algorithms and the models derived from those to begin to learn from data. So if you learn from the data is going to start directing you to, hey, I'm going to show you a pattern or anomaly that you don't necessarily see it within the code. So you begin to use data to spot things that you couldn't do before. I mean, I remember one of my first IT jobs, the CEO of the company wanted us to be able to, this was an insurance company, and he wanted to be able to leverage all of the data across all of the business units and lines of business to start looking at what can we learn not just from each department or each offering, but across all of these to truly understand our customers and prepare for, the next generation, what's coming next. And it couldn't be done then. This really begins to open up the world in a much more sophisticated way to really put data to use.
Great.
Yeah, I'd like to add.
Go ahead.
So besides the cloud and all these technologies, sort of an apex where nearly every business can do machine learning, there's also vendors have come out with tons of software tools that abstract a lot of the complexity of machine learning. So machine learning isn't just the purview of, PhDs who have studied data science for, decades, but now, business analysts can use some of the machine learning technology without needing to necessarily understand all the fundamentals of the underlying algorithm.
If you can help me though, look, can we take one step back and start with a little taxonomy or even definitions in that? Can you describe, Dan, the difference between AI, deep learning, and ML, maybe even cognitive? Because there's a lot of folks in the industry that tend to use it interchangeably. And I got to say, I'm even guilty at times of doing so.
Or if you want, I can get started and then Dan can pipe in. Let's start with the idea that we have an umbrella market or umbrella category called artificial intelligence. Now, I don't think that the word artificial intelligence is going to be with us in the long term because we're really not talking about artificial intelligence. There's nothing artificial about it. What we're talking about is the ability to augment intelligence, and that's human intelligence and machine intelligence. You put those together, and so if we can change the word artificial to augmented, then we start to get to the core of this. So if we think about AI as this sort of umbrella term that encompasses a lot of the key areas that we're focused on: machine learning, neural networks, advanced analytics, predictive analytics. All of these are sort of the capabilities that are under the category of augmented intelligence. And Dan, maybe you want to talk about that a little bit.
Sure. So as Judith explained, we see AI as sort of the top level way of describing all these different technologies. And then within AI, you've got reasoning, you've got NLP, which is natural language processing, you've got planning, and then you've got machine learning. And so machine learning is its own area within AI. And then even if you want to go deeper, within machine learning, you have a number of technologies. So one of them is deep learning and neural nets. You got some other things like supervised learning, unsupervised learning, reinforcement learning. And those are sort of the four fundamentals within machine learning. And then you can even go deeper within each one of those categories into different algorithms for supervised learning, different deep learning techniques, and you can keep going deeper and deeper and deeper.
So thank you for that. Here's a question I have. I'm just curious: is machine learning today premised around software writing software, or is it really in terms of bettering the algorithms to predict and to to prescribe the outcomes that you're going after?
Well, oftentimes I think machine learning is depends who you're talking about. Oftentimes everyone is just obsessed with the algorithm. However, sort of what we see is, experienced data scientists will often choose different algorithms that they like to use. I mean, you have some people who always use a neural network, even if you don't necessarily need one to solve that problem. And then you have others who just say, oh, you can do that with a regression algorithm. The way I see it is right now, it's machine learning. Machine learning is focused on algorithms constantly improving the underlying model. So it's not improving the algorithm, but instead improving the model. And then, of course, to improve the model, you need good data and to frequently update the model. So it's no longer, you aren't creating a model and then setting it out and leaving it alone for 6 months or a year. But we're seeing companies continually adding data to the algorithm to iteratively update the model.
You mentioned this in the book. Where does the line of distinction reside between supervised learning, unsupervised learning, and reinforcement learning? Where are we kind of at today? Where's the focus? Can you give me some information around that?
So when we think about supervised learning, that's most of what we do today. And supervised learning is you sort of know the area that you want to focus on. You know that you understand the nature of the data, and you let that, you sort of, it's very structured, and the problem is relatively well known. So you know exactly what type of data, what type of model that you need, and you apply that subset or that cluster of data to that problem. Unsupervised learning is when you don't really know what the data is going to tell you. It's more of a free-for-all. You're going to throw a lot of data at it and then see where the data leads you. So it's a very different approach. You obviously, for unsupervised learning, you need a lot more data. You need to be able to cluster that data and iterate on that quite a bit. It is starting, I think we're much earlier in the use of unsupervised data. Because it's best suited for what we call unlabeled data, social media, things like Twitter. The data is looking for patterns, but it's not always really well understood. So like in healthcare, you might be collecting huge amounts of data about a specific illness or disease to help doctors understand the patterns of symptoms, but you can't go in and sort of label, I know that this data is X, that data is Y. You don't have the ability to do that. So now there are techniques that are evolving to help you, even if the data isn't labeled, to help you incorporate labels into that, and it determines what the labels are. Now, reinforcement learning is what we call a behavioral learning model. Those algorithms get feedback from the data, and the user is guiding it to outcomes. It's in a way it's another form of supervised learning, because the system isn't trained with the sample data set. Rather, the system learns through trial and error. So, for example, you would use reinforcement learning to manage the movement of a robot. You might use reinforcement learning for a self-driving car, and which of course then leads us into neural networks, which is a form of reinforcement learning.
So and from a consulting standpoint, where do you spend most of where are you helping most of your clients?
So what we are finding is that the sophisticated scientist doesn't need us because they understand what problems they're solving, and they love to work with models and algorithms and tools. It's how am I going to put together a strategy that allows me to use this sophistication to better understand my customers, to do a better job in using this as a strategic tool and as part of my business strategy.
Yeah, as Judith was saying, what we're often doing is helping companies spot areas where they can apply machine learning and these different learning techniques. So oftentimes we encourage people to look for a quick win rather than trying to solve every problem that your company has. Is where can you apply some machine learning for a complex problem, but one that you can sort of get a proof of concept done in maybe a couple of weeks rather than a 6-month project. Because where we've seen companies fail with machine learning is when you have a massive project, it's going to take a year to develop. At the end of the day, you didn't have a clear business problem, and you might have some interesting insight from using machine learning, but you don't really have any results to show.
It's interesting to me that you say that, because I visit a ton of clients. It's part of my role. And I find that a lot of clients, as unbelievable as it may seem, are not defining the problem before they're implementing the solution. Like, by example, I was talking to a client the other day, and they were talking about how they made the transition to Hadoop. But then they went on to tell me how they were structuring everything, getting everything in Hadoop structured. And the more they went on, I was sitting there thinking, well, what would be great for that is just a relational database. I'm not sure why they went to Hadoop. And I think sometimes they got that on a check mark, but almost looking for magic. Is that crazy? Or, are you guys seeing that too? I guess you are.
No, that was really what Dan was talking about. So what we see a lot is when you're letting the technical developer, the expert, the data scientist drive strategy, initially they may be interested in cool tools that they can take advantage of. The reality is, I sort of tell a joke that if you're trying to measure the distance between 2 points, a ruler is the best tool to apply to the problem. If you start with cool technology as opposed to what you can do with it. And it's funny because I see this both from customers who say, we want to use Hadoop. We want to get into machine learning. We want to use AI in our business. You first have to start with what problem you're trying to solve. And I see the same thing with emerging vendors in the spaces like this. They will say, we have a cool tool, but then they'll forget to talk about what problem does that solve for your customer.
Yeah, the way I handle that, it's very difficult, is usually I bring it back to what data that they have at the hand, and then I identify where they are in the maturity curve. And what I find out is they're often still in data preparation. And then we talk about, okay, what problem you're trying to solve again, and then match that back up. But
right.
That's like a pervasive issue that I see across the industry. They're going to Hadoop before they know why. Hadoop's great. It's just, it's got a perfect use case. Anyway, yeah. It's interesting that you're seeing the same thing. So this brings me to another story in that I had a keynote at a client success conference some time ago, and I walked out of the keynote, and it was in the area where they had all the booths. And there was one booth that had talked about client support with artificial intelligence. So I went over to the gentleman that was leading the booth, and we started talking. I used the knowledge that I had, and we started talking about algorithms. I started talking about data science. I started talking about tools, kept going on. And all of a sudden, he, at some point in time, he paused and said, because we are using this in IBM, we're using Watson to identify problems, kind of like you've seen for those that are listening, in the Jeopardy game. So it really works for us well. But he paused for a moment and he said, this isn't like IBM Watson or anything. And almost under his breath, he said, these are just fundamental statistics and some algorithms. So my point in that is, and I was kind of like, my point in that is I see machine learning deeply in research and development. I also see companies grossly stealing the name, even AI or otherwise, to just get attention because it's the theme of the day, if you will. But I also think, to your earlier point, unlike ever before, we got data sets, we got tooling, the plummeting cost of compute and storage. ML can be a reality, which brings me to my question to you. What's your view on the practical implementation of ML today? And where are you seeing it applied in providing real impact?
All right. Yeah. So some of the most common areas where we're seeing machine learning use is financial services companies who are often ahead of the curve in terms of technology investments are using it in all sorts of areas. So for instance, fraud analysis, if you want to, they need to make instant decisions on every single credit card swipe on whether this is fraudulent or not. And if they allow fraudulent charges to go through, they have to reimburse the customer. So that's a huge area where we're seeing companies using machine learning, where you're looking at the patterns of the customer, you're looking at where the purchase was made, how large is the purchase, what time of day is it, maybe whether or not that the customer is traveling. Other areas that we're seeing machine learning is, of course, retail. So everyone has seen on Amazon, customers who bought this also liked this and that. We're seeing machine learning being a big part of e-commerce sites' efforts or strategy. Another way is also security of systems. So looking at network security along with employee activity to sort of spot sort of the next generation of security operations centers are implementing a lot of machine learning to give context to their traditional security devices. So, they have thousands of alerts a day that this behavior might be malicious. Well, if you're able to look at that data in context, you might be able to eliminate 75% of those rather than having to have an analyst spend 2 minutes looking at this alert just to say, nope, it's not important.
So let's talk a little bit about that technology, though. In your book, you provide organizations recommendations on how to, get started, apply machine learning. Can you summarize some of those key points?
So in terms of getting started, you have to be educated. And as we were talking about before, you also have to understand what the business problem you're trying to solve. It may be the type of problem that a traditional BI tool will solve. So you have to make sure that you have enough data, that your problem can be supported by a sophisticated machine learning model. But in many cases, what organizations are finding, they have a lot of hidden data. They have a lot of data in places where they don't even think that they have data. They have data from, maybe from partner organizations. And they also have to understand, okay, what are the data sources? What type of data are we talking about? Where is that data? Do I have, data silos across, 30 different divisions of my company? So first you have to understand what your problem is, where the data is, the nature of that data, and only after you've done that and understand, what's holding you back and the problems you want to solve, only at that point can you begin to sort of take it to the next level from a business perspective. And then you also have to then look at, what the resources that are on the market can help you. So, figuring out the tools and technology that are a best match for the problem you're solving. And you don't want to go from that point to all of a sudden investing millions of dollars in a massive effort. You want to first do a pilot project, and you want to gate it so that it's manageable and something that you can do in a few months, because that's the only time you'll really be able to understand the impact of what's possible, because you're doing something that's manageable. You can get a quick result, or maybe you fail, but you learn a lot from that. So being able to sort of pilot and sort of try things out is quite important here. And then evaluate what you've done. What happened? What worked? Did we suddenly learn new things that we didn't even understand before? Has it taken the biases out? Were we making assumptions that the data is telling us, no, that's not true? So once you have the pilot and you have some failures and some successes, that's when you can begin to build, a true plan to involve data scientists, involve some of the higher level tools that are beginning to come onto the market. So it can help you. Some of the tools that I really like is the idea that you feed the tool your data, and it helps you determine which is the best algorithm and the best model to solve your problem. So things like that, being able to pre-train some of your data. So if you're dealing with a specific problem, you can use pre-trained data, which will save you a tremendous amount of time.
So thank you, Judith. Where do you think we're going in the future now? And I was pleased to see that you had a future section in your book as well. I mean, do you think we're heading toward machine learning as a service? And I guess the second part to that question, if you can answer it, is how does the little guy compete with the IBM, the Facebooks, the Googles of the world as it relates to machine learning, or do you see it purely as complementary?
When you say the big guys, you mean from a vendor standpoint?
I mean, it's an open general question, but you look at IBM, Google, I mean, they've got armies, focused on augmented intelligence, focused on machine learning. And if you're wanting to compete against them, I mean, what is as a little guy trying to get into this space, what should you be thinking? Using their platform or?
Well, I think it's complementary because, you can use some of the machine learning tools from, the big guys, so the IBMs, the Googles, but smaller companies, research groups, other vendors, they're going to have unique data that IBM or Google doesn't have. Hospital might have imaging data that no one else has. And so I think it all comes down to the data. And if you've got unique data or a different way of looking at that data, it might be just, taking Twitter data or some other data that's publicly available, but then augmenting it with your unique data, and you're going to have output that other people aren't going to have.
So that's very interesting. Thank you for that. So let me let the listeners know that very quickly where they can find your book It's on ibm.co/ML4FOR Dummies. Again, ibm.co/ML4Dummies. I'd like to do a quick lightning round, just to ask a few personal questions. Don't worry, they won't be that personal. So our audience gets to know you a little bit. So quick questions to end. Thank you so much again. Judith, I got to ask you this question. So clearly you're an entrepreneur. You're on several boards. You also seem very technical as well. How do you manage being technical and still running a business?
Well, I've got great people like Dan helping me. And, I think one of the little secrets is, as I said, there's nothing new under the sun. So when there's an emerging new technology that I pick up on, I know where it came from. And, I typically have done, research or consulting in that area. And so I can say, okay, I know what that is. And then it's not a big leap.
Very good. So Dan, a similar question to you. So you've got this book, you've written it with Judith. How do you find the time? I mean, I find that leaders have some form of practice or cadence that they get up every day, they do some kind of, they write, they work to learn. I mean, do you have a practice or cadence that people could learn from?
Well, I subscribe to a few newsletters that I always like to read every morning, some email newsletters. And then I think, the way that Judith and I work is we try and collaborate on nearly everything. So
it's teamwork.
Exactly. So I think it's passing things back and forth. You're struggling with something, hand it off and take something that they were doing, and sort of collaboration and teamwork, I think.
Hey, one last question. I am a collector of books. And that's why I'm so interested in Machine Learning for Dummies. So the first recommendation I'll give the community, go read Machine Learning for Dummies. Having said that, are there any other books, and all your other books, by the way, but any other books that you'd recommend that you think are just stellar and that, people should read? I keep a list because I try to get through them all.
Well, I would definitely recommend our other book, Cognitive Computing and Big Data Analytics. It goes through a lot of these issues, and it puts it in context with a lot of issues around unstructured data. So I recommend that you get a hold of that. God, there are so many good books. I'm off the top of my head. I can't tell you the authors and the names, but when I was doing the original research for the cognitive computing book, I read a bunch of books on machine learning, NLP. NLP is getting natural language processing, getting so hot right now, and there's some really stellar leaders who have written very technical but approachable books in those areas. Sorry, I can't remember the names off the top of my head.
Fair enough. Anything else you'd add, Dan?
No, I mean, I think Hurwitz books are great. Then also, there's an interesting book, Everybody Lies.
Everybody Lies. Oh, that did. The name is interesting.
Yeah. Now there's another book. Yeah, I cannot.
That's all right. All good. Hey, just for the listeners, one last time, ibm.co/ML for Dummies. Go get it, live it, love it, learn it. Judith, Dan, a pleasure having you today. Thank you for joining. I've learned a lot, and I appreciate it. Until we run across one another again, thank you so much, and I'll talk to you next time.
Excellent. Thank you. It's been fun.
Great. Thanks.
Thanks, Dan.
Thank you.
Thanks for listening to the Making Data Simple podcast, where we make data fun. Be sure to visit ibmbigdatahub.com/podcast to access the show notes and uncover even more great episodes. Remember, the views expressed here are those of the host and its guests and do not necessarily represent the views of IBM. Until next time, over and out.